Hello guys, welcome back to the angles, line and polygons topic, and today we're gonna consider triangles. So basically triangles is an enclosed shape, and like any polygon it has three sides. So basically any triangle should have three elements. First of all, three sides. They might be different, and according to how they are related to each other, triangle might be scalene, so for all different sides, isosceles for two equal sides the same, so two sides the same, and equilateral, all sides the same. Now about other elements. So here are points where two adjacent sides intersect. So basically they're called vertices. So it's better to mark each vertex as using Latin, so A, B, and C. So opposed to A, it's better to use small a to mark the side lines, opposed to the B side, and opposed to the C side. But it also has three other elements, which is called angles. So here is angles alpha, or you can use angle A, or using another notation like BAC, like angle. So that's the same as angle A in this trivial case, and also as angle alpha. And so measure in degrees or radians. So most of the case in degrees. Next one, so we have beta or B, and the last one might be gamma or just C. Okay, so we have three basically elements: sides, three sides, angles, three angles, and vertices, three vertices. Okay, let's go to the properties. All triangles have the following properties. The sum of the interior angles of the triangle is 180 degrees. So we go back here, and in order to write this rule, and this rule tells that the sum of all of the interior angles of the triangle is 180 degrees. So I put degrees here. Means that if you take alpha and beta and gamma, and if you add them, you'll get 180. So you probably know from polygon theory that there is a general formula for the sum of all interior angles, sum i's. So where I stands for interior angle. So what it means? It means that we have the formula n minus 2 times 180, well known from polygon theory. If you know that, that's okay. You just simply plug, in our case, number of sides n equal 3 in order to find out what stays for our case. So sum of all three angles, simply alpha, beta, and gamma together, we'll get the following. 3 minus 2 is 1, and 1 times 180 is simply 180. Okay, but some student might ask the question, so this formula is actually probably, we need to prove that. Okay, we're not gonna prove for polygon, but actually we'll try to prove it for triangle. Let's try to remember and try, guys, to estimate and assess my approach to that problem. So, indeed, you know that triangle we can arrange from a rectangle. So first of all, we prove for right angle triangle. So first, we prove for right angled triangle. I use this notation in order to denote that we have right angle in exactly triangle. So in this case, we have this delta sign stays for triangle, and we actually can put the diagonal in order to have a triangle here. So we have 90 degrees here. Let's mark this angle as alpha. So obviously this angle is also alpha, right? We have the second line and two parallel lines that I denote with the arrow. All right, so by definition of the rectangle, we have two parallel lines that are opposite. So obviously alpha and alpha will be identical. So obviously here we can mark another angle. I put a red one and I put beta here on beta, and this angle also beta. So in this case, those two parallel vertical lines over there, or segments. In this case, in this second line, so they're also parallel. Just remember types of angle. Make sure you understand that. So in this case, we understand that two triangles basically identical. So what to figure out? We know that for rectangle we have all four angles 90 basically times 4, which is 360 degrees. So that means that for one triangle, let's say for the first triangle and for the second, we have equal amounts of alphas, betas, and 90 degrees. So it means we have a half of 360. And indeed, we have 90 degrees plus alpha and plus beta, right? And because they're equal to also 9 alpha and beta, so we can figure out that alpha and beta is 90 degrees, right? So from where? Because they arrange 90 degrees angle here, for example. So in total we have 90 degrees here, and if we sum up 90 degrees for triangle 1 plus alpha and beta, which is also 90, we'll get 90 and 90. So we'll have 180 degrees. So here is like fast and elegant proof. So we prove it, but unfortunately it's not, this case doesn't cover all the cases, right? So how to prove this property for example, for scalene triangle? All right, no problem. Let's try to do it. So let's say we have scalene triangle. So in this case, I think I need to erase that. So just fix this proof here. And now I erase that in order to have scalene triangle. So, and we try to prove it. So the second proof is for scalene triangle. Triangle with all sides to be different. Okay, so let's say we have a scalene triangle. So all sides different. We marked angles is alpha, let's say beta, and let's say gamma here. Okay, what we can do, we can outscribe. Basically, we can make your triangle to be inscribed in the rectangle. So let's try to do that. So I'll put the opposite side with the equal lines of the base of the triangle. So, and I put two vertical lines. Okay, so now we know that two parallel lines and equal in length and two vertical parallel lines and equal in length. Okay, so in this case, what we're gonna do, we just simply need to prove that alpha plus beta and plus gamma is actually 180 degrees. All right, so let's try to prove that. So first of all, we know that this rest part is simply 90 degrees minus alpha, right? We know that's also 90 degrees. And the most interesting is here. So we have 90 degrees minus beta. This is 90 degrees. And we have all the rest parts. So what we can do, we can add all the angles. Add all the angles. And we'll try to see what it equals to. So we know that all four angles at the corners, like angle A, angle B, angle C, angle D, angle D, so they should give you 360. Okay, so let's try to do. So they are actually completed. So if we apply this property, I guess, yeah, we won't go there to where we need. So for this reason, we consider simply maybe two triangles. Yeah, let's try to do. So we consider triangle, put a letter K. So let's consider triangle ABK that we recently proved for the right angle triangle that the sum of all angles will be equivalent to 180 degrees. Yes, so ABK is 90 degrees angle triangle. So that's why we can apply the following. Angle 90 minus alpha plus angle 90 degrees and plus angle, let's mark it X, will have 180 degrees. Okay, so triangle KCD. So D is here. Maybe put more clear letter. All right, so what we have the triangle KCD. So what we know about that, it's also 90 degrees angle, right angle. So we add the following. So 90 degrees minus better is this angle plus 90 degrees and plus the rest part, let's say y, equals also 180. So what we can do, we can actually add those two equations together. And let's see what we'll have. We'll have the following. So 90 and 90 will give you 180. Then minus alpha and plus x. And we also add with the bottom part 90 and 90, 180. Then minus better and plus y equals 180 and 180 will have 360 degrees. Alright, so we have 180 we cancel with 360, and what we're left with, that x plus y is actually alpha plus beta. Okay, from here we stop for a while and let's see at the angle K. So if we agreed to have 180 degrees because it's open angle, right? So x plus gamma and plus y should be equivalent to 180 degrees. All right, so let's prove that. No, not prove, but actually let's write that. So x plus y and plus gamma will be equivalent to 180 degrees. All right, so what we have simply that x plus y is simply alpha and beta. So instead of x plus y here, we just plug alpha and beta. And we still have gamma, so we'll get 180 degrees. And actually, that were we supposed to have. Actually, if we go back here, we'll get the proof. All right, so that's exactly what we wanted to do. So we proved that the sum of the interior angles of any triangle, because we taken the second time scalene, is 180 degrees. So the first property has been proved. Nice. Let's go next. Any exterior angle is equal to the sum of the interior opposite angles. Okay, so let's try to see how to work it out. I erased the space. That was the proof for the first one. I just erased the space here. And let's get started and see how we can prove this second property. Okay, so any exterior angle, let's see, any exterior angle is the sum of the interior opposite angles. So for this reason, we just first put or drop a scalene triangle. And first of all, let's define exterior angle. If you probably know what interior is, interior and side, right? So exterior, we need to put on one side, for example, that one, and this is the symbol E, that stands for exterior. And this statement tells us that exterior angle equals to the sum of the interior opposite angle. So where they are, let's say here, alpha and beta, they are opposite angles to your exterior angles. They are interior angles. So we need to prove the statement that exterior is simply alpha plus beta because they are opposite interior. Okay, so how to prove that? We know that you would take that straight line, we know that 180 degrees is simply an open angle, and it consists of E, let's say, angle X. So we have E plus X. What we know also from the previous property, the sum of the interior angles of the triangle is 180. So what we can do the following. So we can set up that X, alpha, and beta together will give you 180. So what we can do, we need to come E equals alpha plus beta. So it's better to express X through alpha and beta from here. So okay, X from this equation is simply 180 minus alpha plus beta. It turns out to be that if we plug this right part of the expression instead of X, we will have the following. 180 equals to E plus 180 minus alpha plus beta. And 180 will be cancelled, so we come back here to what we're supposed to prove, because E is simply alpha plus beta. So okay, we've done this also. Perfect. Maybe if you know other proofs, probably for the sum of the interior angles of triangle is 180, so please write in comments, share your ideas, and probably give the links to the proof if you have by your own, or maybe you saw somewhere. That will be great. So the longest side is opposite the largest angle. Okay, so let's try to see how it works. Boom, 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 boom. What we have, the longest side is opposite the largest angle. Okay, we have a triangle, and let's say this angle is obtuse, means the measure is more than 90 degrees. So the rest part should be less than 90, right? Because in total, beta and gamma will give you an amount of 180. So because we add alpha, beta, and gamma, and we'll get 180. And if we consider one angle as obtuse, for example, alpha, so if it's more than 90, so we can express alpha as 180 minus beta plus gamma. We can figure out that if it's more than 90, in this case, gamma plus beta is going to be less than 180 minus 90 is 90. All right, that's what I meant. Okay, so if one angle is really obtuse, means more than 90 degrees, so for the rest, for the sum of the rest angles, we'll have 90 degrees. And what we have, the longest side is opposed to the largest angle. So simply we have this side to be the longest. Actually, here I'm not going to prove, because we need, for this reason, we need to apply probably cosine theorem that connects the opposite side with two sides and the angle. So that's why I just write ready to use formula, so that c squared is simply a squared plus b squared if it were like 90 degrees angle instead of alpha. But if it's, let's say, more than 90 or less than 90, we should add minus 2ab and cos alpha. For this reason, we definitely can say that the largest angle, the more the side. And that's it. Okay, so just keep in mind, and probably when we touch the theorem, we'll be able to prove that. And I put this proof and corresponding videos related to trigonometry and related to cosine and sine theorems in the triangles. But right for now, just try to believe and just try to apply as ready-to-use tool. Okay, so actually what we've done, we completed triangles not all the parts, but we mentioned features that are really necessary in order to solve any problems in GCSE and IGCSE level, and also we proved that. All right, make sure you understand the proof, because sometimes you might be asking Higher Tier to prove something similar to it. So make sure you understand. If not, try to rewatch, try to do by your own, guys. That will be fruitful anyway. Hope you enjoy. Just sharing comments, maybe you have other proofs, and I'll share your ideas and try to have feedback from myself. Hope you enjoy. Don't forget to subscribe. See you.